Uh, Today we are going to start the new chapter, and the name of the chapter is vector. So already you know that what is scalar and what is vector quantity, and you also know that that displacement is a vector quantity and distance is a scalar quantity. This all know. So first we'll start with the basic definition of the scalar and vectors. Scalar, scalars and vectors. So what is scalar quantity? The physical quantity which are completely specified by, and write down, scalar quantity. You know about the physical quantities, okay? So the physical quantities are divided into two groups. So one is scalar quantity, other one is vector quantity. So scalar quantity is the physical quantities which are completely specified by their magnitude or size alone. Okay, these are called the vector quantities, scalar quantities. And next one is, our examples will be length, mass, volume, density, speed. These are all the scalar quantity. That means if I talk about the length or if I talk about the mass, you only quantify the magnitude. Means suppose if I say 5 kg of rice, that 5 kg is the magnitude. So if I tell that bring 3 kilo rice from the market, so that 3 kilo rice only required the magnitude, doesn't require any kind of direction. Okay, that is why it is called the scalar quantity. So examples will be length, mass, then time, etc. And next one is vector quantity. So here the physical quantity which have both magnitude and direction. Okay, the physical quantities which have both direction are called vector quantities. Okay, so vector quantities are like velocity. Examples of velocity, acceleration, force, etc. Now scalar quantity there is no problem actually, but in vector quantity if you want to know clearly, so I want to explain that one. The physical quantity which have both magnitude and direction, that is known as the vector quantity. That is the meaning of this one. That means if I say if you say go to the north direction, 2 kilometers in north direction, so this is east, west, north and south, so you have to go to this direction only. That means if you're going 3 kilometers, the direction is specified. That means that is why the displacement, you starting from the 0 and went 3 kilometers in the north direction, then your displacement is become the vector quantity. Now I'll give you some another explanation of this one. Suppose here is one box is kept here. Now suppose you are applying a force in this direction. If I apply a force in this direction, obviously the object will go in this direction, in this way. Okay, so Now if I same object, if I take and if I change the direction of the force here in this direction like this way, then object will go in this direction. Okay, so in the other way we can also write that the vector quantity is that type of physical quantity whose effect changes with the change in direction. So if I change the direction, the effect of that physical quantity will change. What is the meaning of this one? So I am applying the force in this direction, then the object was going in this direction. That was the effect. The box will move in this direction, that is the effect. Now when I change the direction of the force, then the effect also changed. Okay, so also you can write the vector is a physical quantity. Vector is that physical quantity is that physical whose effect changes with the change in direction. So basically we use this definition. The physical quantity which of both magnitude and direction is known as the vector quantity. Examples are this one. Now this is the one type of explanation is required when we are going to explain that the area is a vector quantity. When I'll explain that one, why the area is a vector quantity, you'll understand this one, that why this definition will be useful, that the vector is that physical quantity whose effect changes with the change in the directions. Okay, so that is the thing. Now some other like examples of vector quantities are torque, angular momentum, electric field, magnetic field, etc. So gradually, like when you will learn so many examples of the vector and scalar. So what are the basic differences of scalar and vector? The scalar quantities are specified by the magnitude only, and vector quantities are specified by both magnitude and direction. Next one is the scalar quantity changes with change in magnitude only. Okay, so that you can understand, and vector quantity changes with the change in magnitude or with the change in direction, or with the both in magnitude and direction. It's a very important one. Scalar quantity with some unit can be added or subtracted according to the ordinary rules of algebra. So normal rules of algebra you can apply, but in case of vector quantities cannot be added or subtracted normal algebraic method. So you have to use like vector addition, vector subtraction, etc. So there are, and fourth one is that they are represented by ordinary letters. So I'll tell you how to represent the vector and the scalar, and the representation of the vector with a bold faced letter or the letter having arrow over them. That means if I want to represent the scalar quantity, so I can write in this way, like if I write an alphabet A, that is enough for the scalar quantity. Now if I want to say vector quantity, otherwise use bold letter, or if I write A and the cap, and the arrow on this one. Okay, so this is the thing. Now few informations, like time is always flows in the forward direction, but time is a scalar quantity. So this is the basic definition of the scalar and vector, and how to represent the scalar and vector. So scalar will be represented with one alphabet and ordinary letters, and vector will be represented with the letters and with one arrow. Okay, so you can read this one as vector A. Read this one as vector A. Okay. Now next one is the representation of vector by graphically. So with the graphically, how will represent? So write down the graphically representation of vector. Graphically representation. Graphical representation. Okay. So how to represent graphically? That means you have to use, suppose if I say, I'll take example as a force. Suppose if I say 5 Newton force, 5 not 10, take 10 Newton force, it will be easy for understanding. 10 Newton force. Now this will be represented in this way with one arrow. So see, the arrow is having tail, this is having tail, and this is having head. Okay, this is a vector. So vector will be having tail and one head. Now if I say 5 Newton force, then exactly it will become the half of this one, like this way, and this 5 Newton force. If I say 2.5 Newton force, then it will be half of this one. If I say 15 Newton force, then you add this one, then it will become 15 Newton force, like this. So and this is the method you can represent the vector in a graphically. So if I say if the 5 Newton force is working in opposite direction, then it will be like this, in opposite direction, 5 Newton in opposite direction. Okay, so if I say this is a P vector, then P vector will be represented as AB. If I give the name, this is A and B, then it will be written AB with a vector symbol on the head. It's very important you have to give that vector symbol, otherwise it will not be understood that whether this is a vector or scalar. So that arrow head, this is very important. And remember the arrow will be from left to right. Don't put arrow in this way. This is not correct. This is not correct. Okay, you have to put arrow in this direction only. Now next one will go to the types of vectors. So today we'll learn only up to types of vectors. So what do we can change the page? So types of vectors. So basically the vectors quantities are divided into two categories. One is polar vector and another one is axial vector. So first one is polar vector, another one is axial vector. So first I will explain the polar vector. So what is the definition of polar vector? Polar vector is the vector which have a starting point or a point of applications are called the polar vectors. So write down the definitions. So polar vectors which have a starting point or a point of application are called, you can write vectors, yes, are called polar vectors. What is the meaning of this one? Suppose if I take an object here and applying a force in this direction, we know the starting point is here, the force is working in this direction, there is a force applied in this direction, so this is known as the polar vector. And another one example I give you. So consider a car is moving in the eastward direction. Let it travels 1 kilometer along this direction. So displacement of the car is equal to 1 kilometer due to east. Okay. In this case, the direction of the displacement of the car and its direction of motions are same along the east direction. That means we know that the vector is going in that direction, and also we know the starting point of the vector. Suppose the object is going in this direction, one car is going in this direction, like this way, in this way it is going, and displacement also know in this direction. So we are having the same starting point. That's also called the polar vectors. We know that where the vector started. That is the main thing I want to tell you. And another example is there that I am going to read out, that the vector quantity whose direction is along the direction of the motion of the body or the particle is also known as the polar vector. Okay. So now next one will come to the axial vector. First, here is the definition. The vector which represents rotational effect and act along the axis of rotation. So that is known as the axial vector. So I just explain this one with some, just a minute. Look at this object. Okay. So I want to open this one. So I have to apply this force, one force in this direction and another force in the opposite direction, like this way. I'm applying the force in the opposite direction, so the object is opening. Okay. Now, so if I apply the force in this direction and if I apply another force in this direction, then it will not open. Okay, it will not open. But when we apply the force in this direction, it will open. Okay, that is known as the torque force. When we apply one force in this direction and the other force in the opposite direction, the torque will be produced. Then what is the direction of the torque? The direction of the torque will be along this axis. Means it will work vertically upward, like this way. It will start from here and go upward direction. Okay, so that is known as the axial vector. Even opening this one, it's going upward direction. See, going like this way, upward direction. So that is known as the axial vector. That means what is the main difference between the polar vector and axial vector is that the polar vector, the starting point, it was known when it started, but in this case, if I am applying a force in this direction, but object is rotating in this direction, but the vector is working towards the axis. So this direction is rotating, okay, and this is the axis of rotation. So say omega is working on the axis, in this axis. That is called the angular velocity. Omega is known as the angular velocity. Okay. Another one is the torque. If you think, suppose object is rotating in a circular path in this way. If I apply force in this direction, force, that is the radius F and R. You know this one. Torque tau vector is equal to R vector. Cross, when we learn cross product, then we will learn this one thoroughly. So this is the torque, remember, torque. So torque is a axial vector. So are the examples of the axial vector: angular momentum, angular velocity, angular acceleration, etc. These are all the axial vector. So today is up to this one. Next class we will continue with the position and displacement vector, and other different type of vectors are there, and some important definitions. Okay, thank you very much.